morning, everybody. Thanks for coming. My name is Vikram Gupta. I am the Chief Product Officer at Synaptics. I also run the IoT processor division there. So today what I'm going to talk about is context-aware compute for the IoT edge. I'm going to give you a flavor of how we look at the whole edge landscape. And also, as part of that landscape, try to give you a sense of how we look at what kind of silicon is required and what kind of architecture is required for that silicon to be effective for certain segments of the edge AI space. And we'll end with questions if we have time. Okay, so you're all aware of the overall edge landscape that everybody talks about. So this is basically showing processing across the edge space. And if you look at it, you start from the left-hand corner, which is, all the IoT devices that we actually are very familiar with, all the different applications, going all the way to access edge and ultimately to the cloud. Clearly, when we talk about the IoT, we don't consider the access edge and the cloud piece. And when you look at, the kinds of devices, the processing devices that are used in the IoT device edge, they range from MCUs, traditional MCUs, going all the way up to MPUs. That's what we have shown here. And one of the things that is happening clearly is that in the device edge, you're seeing a lot of infusion of AI being considered for a variety of applications. And as part of that infusion, it's changing how people look at these IoT processors. And so just to put things in context, again, you have MCUs and you have MPUs, and if you start with the MPUs, they will have enough processing power as well as AI processing that makes them capable to do a very wide variety of tasks. And so inherently, MPUs are going to be capable of a number of different things and it's going to make them very multimodal as they're able to sense a variety of different modalities. On the other extreme, you have traditional MCUs, and there will be a space for traditional MCUs because you'll always need, these very simple microcontrollers doing very specific functions for a given application. That's always going to be there, but there's going to be a category in the middle where the MCUs are going to be requiring a boost in performance as well as some AI capability to actually do some really interesting things. And the focus of my talk is going to be around those multimodal AI MCUs specifically. We think that that's a very interesting class of device, and it's going to open up a new set of applications and also allow for a whole range of sensing modalities that will give a very different experience. The other thing which we think about from an IoT perspective is that the way people think about sensing, that's changing. So in the traditional sense, you're all very familiar with light, motion, and distance being things that we measure or we sense. And you can see that from an ambient light sensor all the way to time of flight, ultra wideband, these are sensors that we are used to seeing in different applications. But what is happening now is that there is more focus on modalities like audio and vision, which are adding a whole new category of sensing that will actually enable IoT devices to perceive the environment in a much better fashion. And that's what will make them multimodal. So when you have, for instance, audio and visual sensing, you can actually sense someone or something. You can classify them. You can actually look at what kind of attention they have in the scene, as well as identify and then depending on who you identify, you can actually personalize that experience. So the vision modality is something that truly gives intelligence a new meaning in the context of the IoT. And for us, we think that the confluence of both audio and vision is really going to make devices much more capable, which will make them sense the environment they're in and then offer a very contextually aware ability to actually interact with the environment and make them much more effective. So we think that's going to be vision and frankly audio are both going to be very relevant to really make multimodality happen in the context of MCUs. So I talked about AI MCUs in the previous slide and where they fit in. It's a category of devices, and they're going to get enhanced with vision and audio capabilities. So what does that mean when both of those things come together? So the way we think about it is that it's going to actually help create this whole new category of devices, which we are calling these AI MCUs. And these MCUs are sort of, if you can think of the traditional MCUs, these actually will scale up and do a lot more intelligent things, as I described. And they're obviously going to be a notch lower in performance compared to the MPUs, which are very power hungry. They have a lot of performance. But these AI MCUs are going to be very savvy about how to ratchet up the performance, but still be very energy efficient. So that's the beauty of it. So they're actually devices that exist between the MCUs and the MPUs, if you can think of it in that sense. So these devices are also going to have elements of being like traditional MCUs because they power systems which are going to be very battery sensitive. These devices are going to have this capability of being always on, and in that sense, they take the characteristic of a traditional MCU by being energy efficient, but they also go all the way up to the high performance and sort of mimic the behavior of some of the MPUs as well. So they're in a very interesting spot, and that's going to help traditional MCU applications become more intelligent, and also create a whole new category of applications that are going to be very AI friendly as we go forward. So one of the things today that we observe with the rest of the industry in general is that if you look at it, there's a lot of MCU silicon out there, and a lot of providers who offer those silicon, but they use very traditional approaches from an architectural point of view, and in a lot of cases the AI is bolted on. And the other aspect is that from a user experience perspective, there are very well-defined ecosystems, but those ecosystems look like walled gardens. They are not, very conducive to actually enabling AI in a very effective fashion. And frankly, what we see is that there's a whole bunch of fragmentation that's happening. So users are confused about how to actually get AI productized at the edge. And one of the things that needs to happen is there needs to be a focus in the industry in terms of creating more standards. And these standards are going to help actually have people offer solutions that are going to be able to work with each other. So between these open frameworks and the open source community is, I think, the way we are actually going to be able to democratize AI in the longer term. So we need to really get all of those things put together, the industry standards, the silicon that's defined well, so that we can actually, have it be purpose-built with the focus on AI and a focus on, performance and efficiency to actually give the right experience for the applications it's targeting. So when you put all of this together, what do you want in a multimodal AI MCU? So when you think about it, it should be energy efficient. It should be able to actually have the right kind of performance to do AI. It should be able to sense all these different modalities that we talked about. And that's what will make it special. And the way we think about it is this class of device should be able to go from a really low power state, the always on state, where it's able to sense something has changed in the scene, to going to an efficiency domain and using intelligence there to actually see if, is there really someone, there was some change detected, is there really someone out there? And then if it wants to do something more, actually go into the performance domain and actually use algorithms and models to classify what was detected in the scene. So if you can think about it, it's these three different gears, and there's a whole, under the hood, the firmware should be able to actually seamlessly migrate from the always-on mode to the efficiency domain to the high-performance domain. So that's how you get the best of both worlds, the efficiency on the one side from a battery perspective and the performance on the other side. So we think that this kind of an architecture is what will actually be really effective to create this class of multimodal AI MCUs. If you're able to do that, you can start seeing applicability across a whole range of applications. And this is just showing some of the applications that we think about. So in the context of smart TVs, for instance, you can detect, if someone is walking into a room, you detect them, and then you're able to actually turn on the TV, or if you want to kind of look at, actually creating a better audio experience, knowing where someone is sitting can actually help you do beamforming so that you can get the right kind of sound to suit their preference. And eventually you can also use presence to kind of look at analytics. Again, privacy is another issue in that context, but these are things that you can do as an example. So you can see that in the case of smart TVs, you can do things with presence and actually detecting someone. The same is true for the industrial space, elderly care, and then also for smart home automation. So this is just giving a sense of some of the applications that you can actually use these AI MCUs for. And you can extend this list, but it gives you a sense of how we think about what these could mean for some of these applications. So last year we introduced the SL-Series, which are Linux-based processors, as part of the Astra family from Synaptics. And today what we are announcing is this SR-Series. So this AI multimodal contextually aware MCUs that we talked about are going to be released under this SR brand. And we're going to offer 3 different MCUs right out of the bat. And to actually use these and play with them and develop applications, we have this a really small dev kit, which is called the Machina Micro Dev Kit. And it's consistent from an experience point of view to the Machina that we have in the MPU side. So we're continuing in the same brand under the Astra family, but it's called the Machina Micro. So this is something that we're announcing and releasing today. These are available today. You can sample. Samples are available, and it is going to go into production in the next quarter. And finally, just a quick plug from my side. So if you have an opportunity to come by our booth, you can get a chance to see all these demos that we have which have been put together working with some of our partners. And we're very proud that our ecosystem has actually expanded. And the other thing that I would say is that we remain very nimble as a company to actually partner, collaborate, work with customers. We're open to new ideas, so come visit us. And the last thing I'll mention is that, Synaptics has had a long history of processors. We've been providing processors for very vertical segments. Last year, using that experience and our experience in AI, and also our multimedia expertise, we came up with the Astra line. And in less than 11 months, we have actually made a lot of progress. There's been a lot of traction. Really proud of what the Synaptics team has actually done in this short amount of time. And we absolutely feel like with the announcement of this SR-Series to complement the SL-Series, we're starting to build out the family in a very effective way, such that we can actually have a lot of value creation for our partners and our customers and in the IoT space. So with that, I'll pause. Thanks a lot. Any questions?
So can you talk about how easy it is to get models on the device, any model, any device, and the ecosystem around that?
Yeah, so I think from a model perspective, the way we are thinking about the SR-Series is that we want to focus on very specific verticals. And the way we think about it is having in those verticals end applications in mind, working with that end application backwards, what kind of models are required, and if the customers have their own models, we incorporate them into the device using our tools. If not, we offer some standard models for that vertical. And we think that with that integration, that tight integration and the focus on the vertical, we'll actually be able to give the right experience to the customers. It's slightly different compared to the SL series from a applicability point of view. But I think that from an SR standpoint, given the focus on the energy efficiency and the fact that we have to go from being energy efficient to maybe really high performance, that needs to be a little bit more tightly controlled. So we have tools for that. Good question. No questions? No more questions? I'll be available after this, so if you want to chat or even come by the booth, we'll really appreciate it. As I said, we're always open to ideas and thoughts on collaborating and so forth. And come visit us. We have a lot of exciting things to offer. Thank you.